Good morning, my dear students. Okay, coming to the second problems on Galerkin method. Okay, so far we solved about what the Rayleigh rigid method problem, potential energy problem. This is the Galerkin method. Okay, already in the first while solving the problem number one on Galerkin method, I already told you about how to solve and what are the basic procedure. That is how to solve the Galerkin method procedure. I also told you. Okay, so if you want to solve the Galerkin method problem, you have to remember the six formulas. Okay, so that is six formulas, that is different two formulas for related to bars and two formula related to beams. Okay, if you perfect those formulas, okay, then you have to practice those formula by writing. Okay, on the page. Okay, we have to remember those formula, then only we are going to solve this what Galerkin method problems. Okay, so what do you mean by Galerkin method? So it is a analytical method or it is a approximation solution. So here we are going to get the deflection beam by doing the trial error function. Okay, that is the main purpose. We are that is the what the definition of Galerkin method. Okay, so here in this Galerkin method we are going to use the Galerkin formula, that is integration of 0 to L f of I into R dx. Okay, if you remember the five different steps, then we will move on to the Galerkin method problem. Okay, so here coming to the second problem, that is what coming to the second problem, problem on Galerkin method. Okay, so here same I am going to use the what SB as tag 2. Okay, so here look at the different types of problem what we solved in the previous one, that is problem number 2, that is using Galerkin method to find the displacement of a system as shown in the below figure. Okay, look at this diagram. Okay, so this is diagram you have to analyze. It is in the which list? In the formula list. Okay, so this is a bar subjected to a axial load. Okay, so we have to remember the formula. What is the bar subject to a axial load, what is the formula, and what are the boundary conditions. Okay, then only we are going to move the next steps. Okay, so here the bar is given, one end is fixed at a displacement x, that okay, and the material properties are given, that is area and Young modulus, and axial load is pulling at the left hand side, that is what right hand side direction with a length of L. Okay, so the question you have to calculate the displacement at middle point. Okay, so here one thing important thing is, here you have to all the diagram that is related to this approximate solution you have to solve by both the method. This problem can be solved by Rayleigh rigid method also and the Galerkin method also. Okay, so that is the Rayleigh rigid method procedure is different and this is different. Okay, so first you have to check whether in the question you have to check whether which type of which method they are asking. Okay, according to that you have to write the formulas. Okay, don't make confuse here. Okay, so both of this formula can be solved by also RR method, that is Rayleigh rigid method. Okay, so this is the problem they given around this is also very important problem. Okay, so look at the again same first step is what we have to formulate the differential equation for the given equilibrium. Okay, so differential equation for the equilibrium bar subject to a point load which is given by A is equal to dou square U by dou x square. Okay, so this is a stored energy, that is what this is the formula for the bar subject to an axial load. Okay, so I have to list it in the formula list. Okay, so second step is assume the polynomial displacement function. So since assume it is a second order degree is there, so second order polynomial function you have to assume, that is u is equal to a naught plus a1x plus a2x square. Okay, why it is 2D order polynomial function? Because here 2 degree of freedom, that is a 2 degree order will be there. Okay, so that we are going to assume this because we want to differentiate with respect to double integration dou square u by dou x square. Okay, then you can substitute here, we are going to get the value. So because of that reason we have to assume the polynomial displacement function, that is u is equal to a naught plus a1x plus a2x square. This is a second order polynomial function. Give equation number 1 here. Okay, so where a naught, a1, a2 are the constant term, by applying boundary condition you have to calculate those values first. Okay, a naught, a1, a2 value. Okay, so here so at x is equal to 0 and u is equal to 0. Okay, at x is equal to 0 initial, what is the u value here? Substitute here, x is equal to 0 means this is 0 and this is 0, u also first end, that is u also 0, so u is equal to, you are going to get u is equal to 0. Okay, at x is equal to L dou u by dou x. Okay, differentiate with respect to this, with respect to x we are going to what? So what is the condition? This is the boundary condition, at x is equal to 0, u is equal to 0, at x is equal to L dou u by dou x which is equal to p by a. These a and b are the boundary condition. These boundary conditions are substituted in this equation. You are going to get the values a naught, a1, a2 values. Okay, so first is initially, so why it is u is equal to 0? Because here the first end u is equal to, it is a fixed, so you are going to consider as 0. So length is equal to what? Initial length x is equal to 0, so here x. Okay, so substitute in apply boundary condition, that is at x is equal to 0, u is equal to 0, we are going to get a naught value is equal to 0. Give equation number 2. Okay, again this we have to substitute in the equation u is equal to a1x plus a2x square. That equation you have to give the equation number 2. Okay, so differentiate this equation with respect to x. So do u by dou x is equal to a1 plus 2a2 x. Okay, so give equation number 3. So apply boundary condition again, that is x is equal to l and do u by dou x is equal to p by ae. So from the equation number 3, what we are going to get? P by ae, a1 plus 2l a2 you are going to get. Okay, so from this equation again you resimplify this. A1 is equal to p by ae minus 2l a2. Okay, so what is our aim to do like this? Means you are going to get the a naught, a1, a2 value. Okay, so we got the a1 value in terms of a2. Okay, so again u is equal to p by ae x minus 2l a2x plus a2x square. Okay, so this equation, okay, substitute the values of a naught, a1 in equation number 2. So a1 value got, a2 value, okay, so in terms of substitute means you are going to get the a2 value there. Okay, so u is equal to p naught by ae x minus 2l a2 x plus a2x square. Okay, so again resimplify this. Okay, again this you have to p by ae x. Okay, so l a2 value, so here what is the common here? X is the, that is what you just here, x will be the, that is a2 is the common here. So take a2 is the common, so x square minus 2l x. So inside give equation number 4. So like that you have to calculate the displacement. Okay, that u is equal to. Okay, so next what is the third step is substitute the displacement function into differential equation. Okay, so this is what the residual equation is given in the given question. Okay, this ae by dou square u by dou x square, which is called, which is equal to r, where r stands for residual. Okay, so that you have to consider here. Okay, so since we know that u is equal to px by ae plus x square minus 2lx a2. Okay, so do differentiate this equation with respect to x. What you are going to get here? Do u by dou x, which is equal to p by ae plus 2x plus minus 2l a2. Okay, so again differentiate with respect to double term, dou square u by dou x square, which is equal to 2a2. So this is all are constant. Okay, so constant becomes 0. So r is equal to what you are going to get? 2ae a2. So r is equal to what here? R is equal to dou square, substitute that dou square u by dou x square value here. So you are going to get r is equal to 2ae a2. So this is what the residual equation. Okay, but according to the Galerkin formula, what step number 4? So once if you calculate the r, so you have to substitute this weighted residual definition. Okay, from the weighted residual definition, that is Galerkin formula, integration of 0 to l wi x into r of x dx, which is equal to 0. So r of x is equal to what? 2a e2 to wx is equal to what? Where I stands for now how many number of degree, that is a polynomial will be there. So this is for 2 is there. Okay, 2 order is there, you have to write 2. Okay, so same w2 is equal to x square minus 2lx, because a2 is the only unknown. So okay, which one is unknown, you have to substitute here. Okay, so therefore the according to the Galerkin formula, you are going to get integration of 0 to l x square minus 2lx into this, substitute the residual equation again. Okay, ae to a2 into dx, which is equal to 0. So now you integrate this equation. Okay, what are the common constant here? That is what the constant term is. 2ae a2 is the constant. So integration of this, you have to give integration of x square means x cube by 3 0 to l minus 2l, integration of x square by 2 0 to l whole bracket. Okay, substitute this 0 minus this l value and 0 minus l value in this equation. So you are going to get 2ae a2 minus 2l cube whole divided by 3, which is equal to 0. Okay, so again from this resimplify this equation. Okay, so you are going to get a2 is equal to 0. This is this goes that direction into okay, so from this equation you are going to get a2 is equal to 2. Okay, so this 3 goes dash direction, that get. Okay, so these all are constant only. Okay, so substitute a2 is equal to 0. So last one is what? Find the unknown displacement. Okay, substitute the value of a2 is equal to 0 in equation number 4. Okay, so finally we are going to get u is equal to px by ae. So this equation we already calculated in the before. Okay, so u is equal to px, which is equal to px by ae is the displacement at point x in the given beam. Okay, like that you have to calculate what the diffraction or displacement in the Galerkin formula by using Galerkin problem and Rayleigh-Ridge method problem. Okay, so this is also important question. Like this you have to solve the numerical problems by using Galerkin method and the Rayleigh-Ridge method. Okay, very simple Galerkin method problems. Okay, first you have to analyze the 4 formulas. Okay, I will tell about the again procedure. First you have to remember the 4 formulas, read the question, which method they are asking, observe the diagram, use the formula from the list and apply the step number 2, 3, 4, 5, then you are going to get the answer. Okay, so this last equation, so is the displacement at midpoint for what u, this is what u is equal to px by ae is the deflection for what? so this given beam, okay, the calculated answer, okay, use the find the displacement of the system. So this px by al is equal to, this is the deflection for the given beam, that answer, okay. So like that you have to calculate the you have to solve the problems on Galerkin method as well as Rayleigh method, okay. So I hope you understand, or you have to what are the difference between Rayleigh method, Galerkin method and potential energy. I hope you differentiate, or you know that what is the difference up now, okay, after solving all the three different types of problem, okay. So here the main thing is in this model 1 is Rayleigh method is our most important to get to appear in the examination. We have to practice more. So before practicing you have to remember the formulas, all those things, okay. So like that you have to solve the problems on what the problems on Galerkin method problem, okay. So here it is also called as weighted residual method. So in this one, in Galerkin formula will be coming 0 to L integration of f of x into residual into dx, that you have to remember, okay. So like this you have to solve the more problems from the textbook, okay, applying this procedure, okay. So I hope you understand this Galerkin method problem, Rayleigh method problem, okay. Thank you.